today I would like to talk on repetitive statements or loops. Okay, we will see where do we use repetitive statements or looping statements. Okay, I will write one example program so that we can understand where it exactly it can be used. Okay, we have three types of statements are there. One is for loop, while loop, do while loop. Okay, we have three types of looping statements are available. One is for loop, second one is while loop, third one is do while loop. Okay, okay, I will write one program here without using looping statements. I want to print generate 1 to 10 numbers. Okay, I will write one small program. First we have to write hash include okay. It is a header file, it is for printf and scanf. Okay, all this code is included or defined in this stdio.h header file. Include console input output dot header file. This is for in view of clear screen and get ch void main. So, I want to print 1 to 10. Okay. Here I am initializing with 1. Here I is a variable of type integer. Okay. Initially it contains value 1. Now I want to print from 1 to 10 %d I++. Okay. So 10 times I have to write 3, 4, get ch. Okay. Now see here I want to print 1 to 10. Okay. For that reason I am not using any looping statement, general whatever we know up to learned here. Okay. This is a post increment operator. Okay. If you are I believe that you are aware of post increment operators, it will come under pre increment and post increment operators. It is one of the operators. Okay. Post increment means first the old value is printed, later it will be incremented by 1. Okay. I++ means I is incremented by 1, that is the meaning of I++. Just look here, I equal to 1, 1 is stored into variable I. Okay. This %d means it is an integer. For integer purpose we use the here format specifier %d. I++ means 1 is displayed on the screen. Next control comes to next statement. Next statement I++ 2, next statement 3. Here first it is printed 1, here it is printed 2, 3, like this. At last it will printed 10. Okay. If I want to display 1 to 1000 printf statements I need to write on the program. Okay. It is increases the programming. Okay. We try to always try to write in a small code. So instead of writing all these things I want to use in a single statements, that is just look here for I equal to 1. Okay. I less than or equal to 10 times, right. Okay. I++. Simple statement. Okay. Instead of writing 10 times, here I am writing only single statement by using the for loop, okay, thanks to looping statements. Okay. So, that time is saved for us. Okay. Print a percentile d means first I is stored into the I, next now the control comes to here, okay, semicolon here, I is less than or equal to 10. Okay. What is the meaning of 10 means I means what here 1, okay, 1 is compared with 10 which is true, okay, condition becomes true. Okay. Next, whenever this condition becomes true, now the control enters the body of the for loop. Body of the for loop means print a percentile I, just look here, print a percentile I, di means I means what, right now 1, 1 is printed on the screen, 1 is printed on the screen. Okay. Next control goes to again next iteration, that is I plus plus, I is currently I value is 1, now the I is incremented by 1, so I becomes 2, now the control comes to here 2 less than or equal to 10, okay, which is true, now the condition becomes true. Next, now the control enters the body of the for loop, this is the body of the for loop, okay, this is the body of the for loop, print a percentile d I, right now I means what, that is 2, 2 is printed, 2 is printed, okay. This is the example of the for loop statements. Okay. We will get the same output. If you want to display repetitive statements, use the for loops. Okay. Now, we will write the syntax of the for loops. What is the syntax? For is a keyword, okay, initialization of the variable, okay, initialization of the variable, next condition, semicolon, updation, okay, and if there is more than one statement, here we write the statements, 1, statement 2. This is the for loop syntax. Okay. First initialization, okay, next condition, updation. In for loop 2 semicolon are mandatory, it demands 2 semicolons in for loop. Okay. If there is only single statement, these braces are optional. These braces are optional. Okay. It's not required. If you want, you can write, no problem. Okay. These are optional. Okay. What is the difference between looping statements and conditional statements? If statement, okay, whereas if statements execute only once, okay, whereas for loop it executes several times until condition satisfies. Okay, that is the difference between for loop and if condition. I repeat, for loop executes several times until some condition satisfies, whereas if statements execute only once, okay, only once. If you want to execute several times, if you want to check the several times, we need to go for the looping statements. Next we have while loop. Okay, while loop syntax is while, here while is a keyword, initialization of the variable, initialization, variable initialization, here condition or expression, this is the body of the while loop. Okay. Now, we can write the statements here, statement 1, statement 2, end of the while loop. Okay. Here also same thing, if there is only one statement, braces are optional. Here braces are optional if there is only single statement. If there is a compound statement, collection of these statements, we need to write the braces, opening and closing braces. Okay. What is the difference between while loop and for loop? For and while. Okay. Both are same. Both the jobs are same. Okay. For loop and while loop job is same, but every for loop can be replaced with while and vice versa also. But when we know how many times it has to be executed, we go for the for loop. Okay. Use for loop when you know times has to be executed. It has to be executed. Okay. Second one, use while loop when you don't know how many times it has to be executed. Okay. So, it is not any rule. Okay. For every for loop can be replaced with while and vice versa also, and remaining job is same. For example, now just previous program, if you see here, I want to convert the same program into for loop, while loop. Just I am removing while loop, for loop, just I equal to 1, initialization, this is initialization of the variable. Next while, how many times it has to be executed, that is 10 times, right. Okay. Now, the condition, this is the condition, same thing. Okay. But first we write the initialization of the variable I equal to 1. So, here we have to write I++ updation. Okay. Okay. If I am not writing here I++ means only one will be printed on the screen, it leads to infinite loop, because updation is mandatory in for loop and while loop. Okay. If you are not updating that variable, it leads to infinite. Okay. Infinite is mandatory. So, we will write one program for whether the given number is prime number or not. Okay. We will write one program, given number is prime number or not. Prime number or not. Okay. First we write the algorithm. First we know that what is the definition of the prime numbers means, it will be divisible only 2 times. Okay. If you take 3, it is divisible only 2 times, one is that is 1 and 3 itself, that number itself. Okay. So, based on this definition we are designing the program now, whereas 4 is not prime number. Okay. It is more than 2 times it is divisible. So, we know that it is divisible only 2 times. Now, I am writing the algorithm step 1. Step 1, what is step 1? First start. Next step 2. Declare the variables. Declare the variables, okay, of int just I am decreasing the font. Integer. Next step 3. So, how many variables we need? That is first n is the number to be checked whether the given number is prime number or not, and we need I. Okay. Next count. These are the variables we need. Next step 3. Step 3 we have declared now initialized count equal to 1, count equal to 1. Next step 4, what is the step 4? Now, we need to take the input values, So, ask the user to take, ask the user to enter value to be checked, ask the user to enter value to be checked. Next step 5. Okay, now we are asking the user what next step, we need to read the value from the keyboard, right. To read the value from the keyboard, what we have to do, we have one predefined function is there, that is scanf. Okay. Read the value from the keyboard, Next step 6. Next, once we read the values, next use loop, for loop, and use for loop where variable I varies from 1 to n. Okay. Where variable I varies from 1 to n. Next step 7. Now we are in the loop. Now, we need to write the logic here. Okay. What we know that number is divisible by 2. Okay. Means check the number is divisible by 2 or not. Okay, 2 or not. Next, step 8. Step 8. If the condition, if step 7 satisfies increment count by 1, increment count by 1. Okay. So, why we are incrementing here count by 1 means we know that every prime number at last 2 it will be divisible by 2 times. Okay. For that reason we are incrementing here count. Next, step 9. Okay. Repeat from step 6 to step 8 until I becomes n. Okay. Next means that indicates that the steps 6 to step 8 is in the body of the for loop, okay, or while loop. You can use not only for loop, you can use while loop also. Next, step 10. Step 10. Check prime number, given number, that is n is equal to 2 or not. N is equal to 2 or not. Okay. Next, step 11. If step 10 satisfies is true, display n is prime number, display n is prime number. Okay. Next, step 12. Step 12. If step 10 is false, display n is not prime number. Okay. Next, finished. Step 13. Stop. End of the program. Okay. These are the algorithms now we have written for the prime number or not. Okay. Algorithm for prime number or not. Okay. Now, based on these steps, now we convert into the program, C program. Okay. It becomes very simple if you are writing the algorithm. Okay. Now, one by one we will write. Just we will see on the board first step 1, that is start. Okay. Include stdio.h. Okay. This is for common for every C program whenever you are using the printf and scanf predefined function. So, remember that it is a default header files. So, I am writing here start, step 1 start, execution start from main function, execution start from main function. Okay. Next, step 2, what is the step 2? That is declare the variables of int n comma I comma count, that is a step 2. Int n I count. Okay. This is step 2. Next, what is step 3? Initialize count equal to 1. Initialize count equal to 1, that is the step 3. So, I am initializing here only count equal to 1, count equal to 1. Okay. Next, step 4, ask the user to enter value to be checked. Okay. Step 4, ask the user to enter value to be checked. So, here I am asking printf enter any value, any integer value, any integer value. Okay. Next, what is the next step? Step 5, read the value from keyboard. Okay. Read the value from the keyboard. Scanf, SF means scanf, just shortcut I am writing here. Scanf function performs two action. One is reading, because it is an integer, I am writing here D. Okay. So, where we are storing, initially we are storing into n. Okay. I am storing the prime number to be checked into the n. Next, what is the step 6 here? Okay. Use for loop where I varies from 1 to n. Okay. So, here I am asking, just I am implementing that step use for loop where I varies from 1 to n, 1 to n. Okay. Next, I++. Okay. Where I varies from 1 to n means every time it has to be first I 1, 2, 3, in general n times this for loop will be executed. Okay. Next, what is the next step? Step 7, check the number is divisible by 2 or not. So, this is the body of the for loop. Check the means we have to use here for if condition. Okay. n percentile I double equal to 0. In percentile I, okay, double equal to I, and n percentile I double equal to 0 means it has to be executed 2 times only, then only we can say that it is that value is prime number. Okay. If satisfy this one, okay, that is the next step. Okay. If step 7 is satisfies, increment count by 1, count by 1, count plus 1. Or count equal count plus also we can write. Next, step 8 is step 7 satisfies. Okay. Step 8 we have written. Next, step 9 we have to go for step 9. Repeat the step 6 to step 8. Okay. Until n becomes I becomes n. Until I becomes n. Next, what is the next step? Check n is equal to 2 or not. If n equal to 2 or not, sorry, if I think we have written here wrongly, that is count equal to 2 or not, count, check the count is equal to 2 or not. Okay. Next, if count equal to means 2 times, we have to compare, comparison operator. Okay. If this step satisfies if this step satisfies, okay, display n is prime number, display n is prime number means printf n is prime number. Okay. Next step, if this condition false becomes false, means step 10 becomes false, means else part, display n is not prime number, n is not prime number. Okay. Next, step 13, end of the program, stop the program. Okay. This is a logic for the prime number or not. Okay. Now, we will see this one, if there is any errors are there in this program, we will trace this program. First, here count I comma n are the variables of type integers. Okay. These 3 variables are created somewhere in the memory, n, I, count. These 3 variables are created. Initially count contains 1, okay, this is garbage values. Next, we are asking the user enter any value to be checked. We are asking the user enter any value to be checked. Here I entered 5. I entered 5. Okay. User entered 5. This 5 is read from the keyboard and stored into the variable n. Okay. Scanf function is reading the value from 5 from the keyboard and storing into the variable n. Garbage value is overwritten, 5 is stored. Next, we are writing this is a logic, I equal to 1, okay, I equal to 1, 1 less than or equal to 5, 1 less than or equal to 5, okay, 1 less than or equal to 5, which is true, condition becomes true. Now, the control enters the body of the for loop, this is the body of the for loop body. Okay. Next, if n percentile I, what is the n means here 5, that is I means 1, okay, it satisfies, okay, it is divisible. So, 0 comes, remainder is 0, 0 double equal to 0, which is true. Okay. Whenever this condition becomes true, now the control enters the body of the if condition. Okay. Count equal to count plus 1. Okay. Initially it is 1, sorry, we have to write here 0, because it has to executed, it has to be only 2 times, right. So, it should be 0 initially. Okay. Just make the changes here, count equal to 0, okay. Count equal to count plus 1, count means what right now 0, 0 plus 1, 1, 1 is stored into left hand side variable count, this 0 is replaced with 1, 0 is replaced with 1. Okay. Next iteration, repeat the same thing, right, repeat the same step 6 to step 8 until I becomes n. Okay. That is, now the control go back, because it is a for loop, looping statement means it goes to next iteration, okay, until I becomes n times. Now, I plus plus, I is incremented by 1, that is 2, 2 less than or equal to 5, 2 less than or equal to 5, which is true, condition becomes true. Whenever the condition becomes true, control enters the body of the for loop. Okay. This I plus plus is not incremented immediately. Okay. Once it is done, now the control enters the body of the for loop. If n percentile I means what here 2, okay, I means 2, so 2 2s are 4, remainder is 1, 1 double equal to 0, which is false here. So this body of the if condition is not executed. Body of the if condition means count equal to count plus 1 is not executed. Again control go back. Next iteration, I plus plus, I is incremented by 3 by 1, that is 3. Initially it was 2, because of the I plus plus post increment operator, now it is incremented by 1, it becomes I becomes 3 now. Okay. 3 less than or equal to 5, condition becomes true. Again control enter the body of the for loop. Okay. If n percentile I double equal to 0, n means what here 5, I means what here 3. So remainder is it is not divisible. Okay, it becomes 1, it becomes false. Okay, it is not executed. It is not executed. Next, I plus plus, I is incremented by 1, that is 4. That is 4. 4 less than equal to 5, which is true. Again control comes to here. If n percentile I, n means what here 5, I means what here 4. So remainder we will get 1. 1 double equal to 0, 1 double equal to 0, which is false. So this body of the if condition is not executed. Next iteration, I plus plus, I is incremented by 1, that is 5. 5 less than or equal to 5, 5 less than or equal to 5, which is true, condition becomes true, control enters the body of the for loop. If n percentile I, n means what here 5, I means what here 5, 5 ones are 5, remainder is 0, so it is divisible. Okay. Now what we get here 0 double equal to 0. Okay. Condition becomes true, if condition becomes true, whenever the if condition becomes true, control enter the body of the if condition. Count equal to count plus 1, initially count was 1, 1 plus 1, that is 2. Count equal to 2. Okay. Next, next iteration, I plus plus, I is incremented by 1, that is 6, that is 6, 6 less than or equal to 5, which is false, which is false. Okay. Now the control comes out of the for loop, control comes out of the for loop because I becomes n. Okay. Next, now we are coming to here, now we are checking here whether it is divisible by 2 times or not. If count means what here 2, 2 double equal to 2, okay, condition satisfies here. Printf, n is prime number, n means what here 5, 5 is prime number here. Okay. This else part is not executed. Okay. Either if or else, else only executed. Here if condition only executed, that is n is prime number. Hope you understood here this program is a prime number or not. Okay. Next, why we are writing the 2 times here if condition, why I am writing if condition, because we know that that number is divisible only 2 times, then only we can say that that is prime number. So for that reason I am writing here if count double equal to 2, initially I am storing 0. Okay. How many times it is divisible, I am adding to that count. Okay. For this we need 3 variables here. Okay. We are reading the value. Okay. This for loop, here we are using for loop and if condition. Okay. Why? Okay. I want to write inside the for loop this last if. For every time we will get n is not prime number, n is prime number, 2-3 times we will get. Okay, which is undesirable. So, now we will see that arrays concepts. So, what is arrays and how to declare the array and how to initialize the array, okay, and advantage of the array we will see now. Okay. Before writing these arrays, I want to tell something here. Just int a equal to 1 or 2, okay, means what happens, first variable is created, okay, thus address may be 1000, okay, 2 is stored here. Here what is a means here variable name, here value of the variable, okay, this is address of the variable, okay, we know that this one. Here a is a variable of type integer, here a stores the value, okay. Next, in the next statement I want to store some more value, a equal to 4, a equal to 4. So, old number means this 4 is stored in the same variable. So, 2 is lost, 2 is lost, 2 is lost, old number is lost, only new number is stored, only new number is stored. Next, look here, a equal to a plus 1 or a equal to some other number, a equal to some other number, a equal to 5. What happens, 5 is stored into left hand side variable. So, this whole number again it is lost, 2 4 we lost, but I want to persist, I want to store, I need 2 4 as well as a new number, okay. I need old numbers also as well as the new numbers, okay. To get such kind, if you get such kind of situation, go for the arrays, go for the arrays, okay, means we will store old number as well as the new number, okay. Here a is the array, okay. Here a values are elements or values are elements, okay. Here indexes will contains, if you want to access this one, a of 0, a of 1, a of 2, like this, it becomes very simple, okay. So, collection of elements is called array of same data type, okay. Okay, now we will see the slides. An array is a collection of variables or elements of same data type is called array. I repeat, an array is a collection of elements or variables of same data type is called array, and it contains contiguous memory allocation, okay. An array contains contiguous memory allocation, okay. What is continuous memory allocation means, just look here, now we stored here 2 4 5, okay. First to declare this one, int a of 1 2 4 or 3, okay, okay. To initialize this one we write like this, a of 0 equal to 2, a of 1 equal to 4, a of 2 equal to just 5, okay. Here continuous memory allocation means first address, first value contains one address, that address is called base address, base address, Okay. Next, continuous memory allocation means because it is a integer, each variable occupies 2 bytes of memory in case of it is Windows operating system. Okay. Next 1004, next 1000 2 bytes means 6, 1 2 3 4, 4 into 2, 8 bytes of memory allocates. Okay. This is called contiguous memory allocation. Okay. 1000, 1002, 1004, 1006. Just look here, diagram is also available here. Int score of 9. Okay. A scores is a array name of integer data type. Okay. Here 0 1 2 3 4, you can see here these are indexes. This is declaration of an array. Okay. Here we need to mention the size of an array. Next, int scores is a array name. Next, second declaration array, just look here, char name of 10, char name of 10. Your name is the array of type character. Okay. It is also called as string array. Okay. So, string means collection of characters enclosed, it is ends with null character, delimiter is \0, whereas strings. Next, float, this is GPA is a array name of type float. This is a declaration of an array. And just now we have seen that a definition of same data type. What is the same data type means? Just look here, ten, okay. This is employee number, employee name. No, it leads to error. In array I cannot write like this. In array I cannot write like this. I cannot store, because either I have to store integers or else characters or else floats. Okay. In the same array I cannot store different data types. If you want to store different kinds of data types, we need to go for the structures or unions. Okay. That is the meaning of the same data type, or homogeneous collection of elements of homogeneous continuous data type. Means same data type means I have to store only integer, or else I have to store only characters, or else I have to go for only float data type. Okay. I cannot store all the data types in single array. All the different types of variables I cannot store in a single array. It leads to error. That is the meaning of that definition, same data type. Now we will see the how to access the array elements. How to access the array elements. Now we will see this one. To access an array's elements, we need to provide an integral value to identify the index we want to access. Okay. For example, just see here score of 0. Okay, this is accessing. For accessing the array, we have to go for the for loop should be there. If it is a single 1D array, we have to use the one for loop. Okay. If it is two dimensional array, we have to go for the nested looping. These are the accessing of the arrays. Okay. This is look here, syntax to declare an array. First we need to write the data type, array name, and should be mentioned the size, should be mentioned the size. Example, here how much this array will contain bytes occupies in the memory means size and that size of data type and into size of the array. Okay. For example, if you are taking here into a of 5 into a of 5 means it is created of size 5, 0, 1, 2, 3, 4. Why 4 means we are started with 0 index, right. So, this is name of the array. Okay. How much it occupies, name of data type, that is int means each integer variable occupies 2, 2 into size of an array, that is 5, means total 10 bytes of memory is allocated, occupies in the memory. Total 10 bytes of space is occupies in the memory. That is the meaning of the total bytes equal to size of data type. Type means data type into size, array size. Okay. Here this is indexes, these are called indexes. Okay. For, this is called here address. Next address is A+1, next address is A+2, next address is A+3, next address is A+4. Okay. An array starting address is called as base address, base address. A means what? This address of this array, okay, maybe 1000. Okay. A+1 means next address of the second address, that is maybe 1002, like this. An array is also called as constant pointer. An array is also called as constant pointer. Next slide we will see. Okay. Valid and invalid array array declaration of sizes, valid and invalid. Okay. A of 2, it is okay. I cannot write A of -2 size, okay, while initializing the array size. Okay. Where max is a macro. Okay. We can write like this, means already define that macro, define max equal to 100, something like this, then okay. Okay. But I cannot write like this, means size is not variable, size should not be a variable. Okay. Before and declaring only we must mention the size. No problem, we can write. What is the meaning of this one? ASCII value of the A means one fixed integer value can be placed here. Okay, it may be, if A is called 65 means A of 65 is placed here. Okay, if the ASCII value of A is 65, 65 is placed here means integer value. Okay, but I cannot write like this. Okay, that means it is a variable, it leads to variable, it leads to error. I cannot write like this, but I cannot write like this because it is replaced with an ASCII value of the A. Okay, within the single quotes it's okay, alphabets, characters. Just you can see here how to access. Okay, we will write the example program also, you do not worry. Okay, now we will see the initialization of an array. We can initialize fixed length array element when we define an array. Okay, the meaning of this one is we can initialize the values. Okay, once it is defined on an array. Just look here, this is the initialization of an array. Okay, int numbers of 5 equal to 3, 7, 12, 24, 45 within the braces, flower brackets semicolon means 3 is stored into 5 this side array numbers. Okay, like this, just you can see the diagrammatic representation here, 3, 7, 12, 24, 45. Okay, next second scenario here, B, example B, initialization without size, it is also possible. Okay, here I am mentioning size. Okay, here I am not mentioning the sizes, 3, 7, 12, 24, 45. Okay, next see the example C, partial initialization. Okay, int numbers of 5 means of size 5 is created in the memory, size 5 is created in the memory. Okay, but I am initializing only 3, 7, but remaining are wastage, but it is filled with zeros. It is filled with zeros. It is filled with zeros. Okay. Next example D, initialization to all zeros. Okay. If you want to initialize with all the zeros, just write like this. Okay. Within the flower brackets I am mentioning here 0 semicolon. Okay. It is totally all the elements filled with zeros, all the elements filled with zeros. So, we will write one program here. First hash include stdio.h. Okay, you know that I am not writing due to space problem. Execution start from main function. Okay, main is a special user defined function, here void is a return type, I am not returning anything to the operating system. So, first here I am declaring the array A of 10 of size 10, okay. Here I, okay, two variables I am declaring here. Next, once we declare the variable declaration, we need to ask the user to enter the values elements into the array. Printf, PF means printf, enter elements into or values into array. Enter values into array. Next, scanf, okay. Oh, we need to use the looping statements. Next, for I equal to 0, because array indexes starts with 0, here I am initializing with 0, okay. How much size I want to store into 5, only 5 out of 10. Next, I++, I is increment, where I varies from 0 to 5, okay. Remaining sir I am not storing. Next, so we need to read the value. So, I am writing scanf %d, okay, ampersand A of 5. Okay. If you are not using for loop, means we have to write 5 times scanfs, okay. Next, we read the values, okay, up to 5 elements it is okay. Next, I want to print the array now. Printf array is printf %d, okay, tabular space t. T means which gives the 5 space 1, 2, 3, 4, 5 for each printing on the screen. It space gives the space up to 5 spaces. A of 5. That is it. Get ch, end of the program, okay. Int A of 10, okay. A of 10 means array A is created up to size 10. A 0, 1, 2, 3, 4 up to 10, okay. Next, variable I, enter values into I. Now, I entered 10, 20, 30, 40, 50, total 5 values I entered, okay. First I equal to 0 means here I equal to 0, okay. 0 less than 5, which is true, condition is true. Next, reading, scanf means reading, ampersand A of 5, ampersand A of 5 means here the value 10 is read and stored into A of 5, okay. Next iteration, I++, I is incremented by 1, now I comes to here, okay. A of 5, 20 is stored here. Next iteration, I++, here A of 2, okay, that is 30 is stored here, 30 is read. Next 40 is read, 50 is read, Okay. Next, zero to 4, no need to write here, equal to because we have to write here -1, I equal to 5 minus 1, because I varies from 0 to 4 only, 0 to 4 only. So, here I am writing 5 minus 1, because if we are writing the 1, we can write here 5, because already we are index starts with 0 means 4 only. So, 5 minus 1, that is okay. Next, at last I is 6, at last I is 6, it becomes false, control comes out of the for loop, printf. Now, I need the whatever we read the value from the keyboard into the array, I am displaying. Printf array is %d a of I, a of I means what here, a of I means so we have to write another looping statement here. Okay, we made a mistake here. Okay, a of I means last value, that is 6 value, there is a garbage value is displayed here. So, to accessing and displaying, we have to use the looping statement. So, here again I have to write for loop, I equal to 0, I less than or equal to 5 minus 1, I plus plus. Okay, printf %d tabular space a of I. Okay, first I equal to 0 means a of I means 0, 10 is displayed. After displaying 10, we are giving the 5 spaces. Okay, next 20, 30, 40, 50, this is the output. Okay, this is the output. Why we are writing, if we are writing here ampersand here, we will get the address of an array, but not the value of array. Okay, if there is only single statement, these braces are optional, braces are optional. If there is only single statement, braces are optional. Next, I want to display reverse order, means I entered here 10, 20, 30, 40, 50, I want to display in a reverse order. Then how do we write? Just simple changing in the for loop. Okay, like this, for I equal to 5 minus 1, I equal to 5 minus 1. Okay, next I is greater than or equal to 0. Okay, I minus minus, I minus minus. Okay, next same printf, %d %t /t a of I, that is it for reversing an array. This is the logic for reversing an array. I equal to 5 minus 1, 5 minus 1 means what, 4, here a of I. Okay, 4 is greater than 0, which is true. Okay, printf a of I means a of 4, that is 50 is displayed. Okay, after 50 is displayed, we are giving the tabular space, \t means it is a escape sequences. Okay, the meaning of \t means which gives the tabular space. Okay, means something, some space here. Next iteration I minus minus, I minus minus means I comes to I equal to I minus 1, that is the meaning of the I minus minus. Okay, that is now I equal to 3 now. Next, 3 is greater than or equal to 0, 3 is greater than or equal to 0, which is true. Next, control enter the body of the for loop, this is the body. Printf %d a of 3, that is 40. The next iteration 30, 20, 10, 20, 10, this is a reverse of an array, this is reverse of an array. Okay. So, array concept is very important. Next, I have one doubt here. Instead of here, I am wasting the space here, means how much space is occupied this one, 10 into 2, 20 bytes of memory is occupied. 20 bytes of memory is occupied because A of 10, because of the integer means 2 bytes, which occupies 2 bytes in case of Windows operating system. Okay. Size 10 into 2, 20 bytes of memory, but I am not utilizing total size. I am taking only 5, only half of this memory. Okay. So, I am not at all utilizing total entire memory. So, I want to write something like this. Is it possible? A of n, just I am writing here n. Okay. Enter size. Hope you copied this one. Printf, enter size of array, enter size of array, scanf, %d, %n. No, I cannot write. I cannot write, it is error. Okay. Size should be fixed size. Size should be fixed size, but not the variable. Okay. If you want to go for dynamic memory allocation, we have to use the malloc and cloc functions. It's a predefined functions. If you want to create the array of dynamically runtime, you have to go for malloc and cloc functions. Okay, but not compilation time array. Compilation time means it should be a fixed size. I cannot write like this, A of n, enter size of array. Okay, but it is it leads to error. It leads to error. We must write the size only here. Okay, if you don't want to waste the size, okay, if you don't know how much elements we are going to accessing, retrieving from the keyboard, means we have to go for the runtime array, that is malloc. It is a predefined function. It is a predefined function. Okay, it is used for runtime memory allocation. It is not only for array, it is used to create the structures and arrays. Okay, it is a dynamic memory allocation. Okay. Next our concept is strings. Okay. Strings is a collection of characters. Collection of characters enclosed at last ends with a \0, null character. Null character is called strings. We do not have any string data type in C language or C++. But it is available in Java. But not in C. Okay. In C language and C++ we do not have string data type. Okay. But how do we achieve the strings, means we use the character array. Character array. Okay. To achieve the strings we go for character array, okay, or char star. It is also strings, it is treated as a strings. It use the, if you have the good knowledge on pointers, we go for pointers version also. Okay, this is okay. Tomorrow we will see the strings and string handling functions. Okay, thank you.